Hello, so in this week's Module 7 Interactive Advanced Concept presentation, we'll be learning about magnetic fluid. So magnets contain very interesting properties. So in this experiment, we will use a magnet to manipulate a fluid. So we are going to be making a ferrofluid and use a magnet to manipulate this fluid. Alright, so in this experiment, we do have a couple things that we need. We have our toner, our vegetable oil, and our magnet. Alright, so we are going to take our toner and we are going to add 2 tablespoons of vegetable oil to the toner. So we are going to want this to become a thin consistency. So you may need to add a little bit more oil depending on how much ink or toner that you have. Alright, and now we are going to stir this until it becomes nice, thin consistency. And it is pretty much mixed as best as we can get it. Alright, so in this experiment, we can see that a liquid can be magnetic because ferromagnetic particles disperse in liquid to form a colloid or paramagnetic salt liquids. So what would work best for making a liquid magnet would be a ferromagnetic material because of the large magnetic permeability and spontaneous alignment of domains when subjected to external magnetic field. Diamagnetic is when exposed to external magnetic field. An induced dipole movement opposes the external magnetic field, lowering the net magnetic field. With paramagnetic, a permanent dipole movements align with external magnetic field but are opposed by thermal agitations, reducing the attraction. And then with ferromagnetic, spontaneous alignment of magnetic moment of each atom forming domains which are randomly oriented when in an unmagnetized state. So a ferromagnetic material would be the best type of magnetic material that would work best for making a liquid magnet. So there are 3 components to this. There's carrier fluid, and that is what transports magnetic nanoparticles when not induced by magnetic field. The second component is magnetic particle. That's what provides magnetic attraction when exposed to an external magnetic field. And then the third component is a surfactant, which is a chemical that helps spread magnetic particles apart and attach to the carrier liquid. So as you see, liquids can definitely be magnetic, and this was a really easy experiment to perform. Did not take a lot of setup or a lot of time. I hope you enjoyed the experiment. I know I did. Apologize for the way I look for this experiment. This week I've had the flu, not feeling exactly 100%. But again, I hope you learned something from my presentation, and I will see you next week for our last advanced concept presentation.